This following formula, C3H8, you know it as propane. That's what's in your barbecue. So we look at this one and we still have the same problem. We have oxygen in one location here, and it shows up in two locations there. And we have an even, and an odd number. This is where what we have to target every time. But I'm going to show you again how structural chemistry can sometimes help you out. What does C3H8 look like? Like that. And it's bonded to 8 hydrogens. So I'm going to come in here and bond it 8 times. And I'm not going to draw the little vertical sticks in there. I could later. So 3 hydrogens are here, 1 at the end, and this is what it looks like. It really wouldn't matter if you drew it accurately. All that matters is you write down that there are this many of them. But this is why I love structural chemistry, and I wish we did it more, because it really is quite easy. How do we set fire to this completely when all we're adding to it is oxygen? So we have these 2 oxygen sisters right here are waiting to tangle this. And we must build water, we must build CO2. So here's how I would do it freehand. Every time I see 2 hydrogens, or a pair of hydrogens, an oxygen is willing to grab them. Remember, water can be written as H2O, but structurally it looks like that, HOH. The hydrogens are on either side. So for freehand purposes, these oxygens are a little bit big. This is what I would do. I can make a water molecule right there. 2 of them pair off to make a water. I can make a water right there. There's a water. Over here, I stick in another oxygen, and I can make a water.
Adam Vickery, call 219, please. Mr. Vickery, call 219.
That wasn't too deafening. So if you look, I am capable of making 4 water molecules with this. So I'm going to go up here and doodle in a 4 for a moment. Looks like I can build 4 waters. How many oxygens did it take? 1, 2, 3, 4. 4 oxygen is 2 pairs. So it looks like for the moment, 2 pairs of oxygen would allow us to build 4 waters. Now what about these carbons that are left? Well, each carbon is going to burn to carbon dioxide. So I'm going to need to chew up an oxygen and an oxygen and an oxygen and an oxygen and another one here and here. Well, let's count them. 2, 4, 6. I need 6 more oxygens. But remember, they're coming in pairs. So 6 oxygen is 3 pairs. But we already had 2 pairs. So we had 2 pairs for hydrogen. How many pairs of oxygen is this? 1, 2, 3, 4, 5. Looks like 5 pairs of oxygen and 1 molecule of propane would burn off to make carbon dioxide. We were able to make 3 of them and 4 waters. And we did it by just doodling on this. So this is a fallback way of doing it when you're having trouble with the math. Now let's look up here. 3, 3. 8 of these, 4 pairs is 8. 10 oxygens in total. 6 are found here and 4 oxygens there. And again, what does 4H2O mean? Doesn't mean 4 H's. 4H2O means this. There's that many made. And 3 CO2s means this. So I didn't draw out the rest on here because it make a big mess. But that's one way of achieving this, is to use the structural drawing to achieve that. Okay? This ends the third lesson.